All right, composition functions. Let's talk about them. So first of all, we just need to know like notation, what it means. You've probably seen this before, this f of g of x. You might also see this open circle where it means the same thing, f of g of x. Okay, so just think about that. You know, if you ever see either of these notations, you'll probably see this one the most. Okay, composition. We're composing a function within a function. So first example, we have f of x is x squared and g of x is 3x minus 1. I apologize if you heard my dog Charlie barking just there. Anyway, where did I leave off? We need to find these four things here. So why don't you guys put me on pause, do that, and we'll check our work. All right, let's check our work here. F of -3 is 9. F of x plus 1 should simplify to x squared plus 2x plus 1. F of g of x should simplify to 9x squared minus 6x plus 1. And g of f of x should simplify to 3x squared minus 1. Notice that, for example, in f of g of x, I'm literally plugging in g into f, right? Instead of f of x, it's now f of 3x minus 1. Now, it says here, compare the composition of functions to evaluating a function. How is, for example, f of -3 similar to f of g of x? Take a minute to write that down, and then we'll move on. All right, next one. We are given the following functions h of x, g of x, and f of x. We are asked to find h of g of x, g of h of 2, and h of f of g of x. And then we're also going to find the domain where we can. Go ahead and try this on your own. Okay, so I started with h of g of x. I'm plugging in g of x into h of x. Now, think about when we're doing our domain, you have to think about what you had originally substituted in, right? Think about, is there any x value that I can plug into g of x? Because that's what I'm going to plug in first. Actually not. That restricted domain is actually 4/9 to infinity. Okay. For the second one, g of h of 2, pretty straightforward. Plug in 2 into h first, I get 29. G of 29, therefore, is 257. The last one that we had here was the crazy h of f of g of x. So I actually started with here f of g of x just because I thought that was easier to figure that part out first and then plug it back in. So I plugged in g of x into f, and that gave me 9x minus 4. Then I plugged in that into h, which gave me this cubic right here. Now, thinking about the domain, if I look at this right here, my end result from this composition function, I'm like, oh, great, the domain's all real numbers, right? No. Look at what you originally substituted in, right? You would be plugging in x values into g of x first. So therefore, the domain of g of x is actually restricting the domain of this entire composition function. So once again, this domain is 4/9 to infinity. All right, do we have directions on this page? Who knows? There we are. Okay, so we're given some graphs here for f of x and g of x, and we're asked to find f of g of 6, and we're asked to find g of f of 6. That being said, just as a little helpful tool for you guys, sometimes I think it's just easier to write this for some students. Just visually, they understand that better. Then I can go to g of 6 on the graph, figure out g of 6, plug that into f. Why don't you guys finish these two problems here? All right, so for the first one, I got that we should have an answer of 2, and the second one, I got an answer of 0. If you're not really following along with this work here and how I use the graphs to get that information, please ask me or ask a classmate. All right, last part here, identifying composite functions. Find functions f and g such that f of g of x equals h of x. Now, the fun thing about this is that there are many correct answers here. There are a bunch of different functions that I could write to functions f of x and g of x such that its composition would be the square root of 9 minus x. Let's think of the most simple one. Okay, I could make, this one's not really that fun, but I can make g of x be x and f of x be square root of 9 minus x, right? Wouldn't that produce the same thing? I'd plug in x into here, boom, I get the same thing. But that's not that exciting. So maybe let's take that one step further. Maybe we make g of x the inside quote-unquote function or expression, and f of x could be the radical, right? Or I could even make this even more complex here. This one might take a little bit more thinking. It's easier for me to write f of x first. Let me just make that some constant. Let's go 6 minus x. And to figure out what g of x would have to be in order to change that to be a 9 minus x. Anybody? Anybody? X minus 3? Yep. Yeah, that would be one option here, because if I plug that in for x, I would get minus x, good, plus 3, which makes that 9. I would really ask you guys, in your problem sets and definitely on assessments, don't do option number 1. Let's give you guys a chance here. Why don't you guys try to come up with at least one way to decompose this function k of x here. Go ahead and put me on pause. I'll be curious to see if anyone did the same thing I did. Many ways to do this. So I just decided, I saw that there was x squared twice in here, so I decided to make g of x be x squared. And f of x would be negative x minus 5 all over 4 plus x. That would work. I'm sure that there are other answers out there that would work as well, so kudos to you if you came up with something different. All right, so in conclusion, composition of functions is substitution. It truly is. It's plugging in one thing in for another. Whatever is in parentheses goes in for x.